definition show that limit of 2x square plus 3 upon x plus 5 is 3 by 5. So again use the same procedure. So for epsilon greater than 0 we have to show there is delta greater than 0. So we have to find this delta such that this thing, the difference is less than epsilon when x tends to 0. That means 0 less than mod x or mod x minus 0 is less than delta, right? So we consider this difference 2x square plus 3 x plus 5 minus 3 by 5. So by cross multiplication simplify this thing. 10x square plus 15 minus 3x minus 15. 5 into x plus 5. Is that right? For 10x square plus 15 minus 15 minus 3x. Yes. So it is 10x square minus 3x divided by 5 into x plus 5. So as x lies in the neighborhood of or delta neighborhood of 0, so whether x positive or negative, so it does not affect the absolute value of x plus 5. So it can be modulus of 10x square minus 3x divided by 5 times x plus 5. We can take it outside the absolute value because this thing is always positive. Whether x is very small, near to 0, it may be positive, negative, but it will be definitely it will be a positive quantity. Now we can take mod x common, so it will be 10 times x minus 3 divided by 5 times x plus 5. And what changes we should do here? It is 10x minus 3. So this quantity can be less equal 10x x plus 5. So it is, I adjust here, it is minus 3 and plus 50. Why I made this adjustment? Because in the next step what will happen, I will take 10 common from this term, and so it will be x plus 5, so that it will cancels with this x plus 5. Okay, as it is absolute value, so it can be x plus 5 and it will cancel with this thing. That's why I made this adjustment. And what is difference? What is the comparison between 10x minus 3 and 10x plus 50? Surely less than or equal to, right? So it is equal to 5, 10 by 5, it is 2 times modulus x, and I can adjust it as 2 times x minus 0. So what I want this quantity to be less than epsilon. So and with what? X in a delta neighborhood of point 0, right? So it should be less than delta. So actually it is what? Actually it is less than 2 times delta. So what I should have? This quantity to be epsilon. Therefore if we choose a delta to be minimum of 1 and if 2 delta is epsilon, so what a delta should be? In this case epsilon by 2, which is positive, then for any epsilon, any given epsilon greater than 0, this difference is less than epsilon when x belongs to a delta neighborhood of 0. That is limit of 2x square plus 3 upon x plus 5 when x approaches to 0 is 3 by 5. Okay, so try to solve some more examples. And now we go to the next section, which is the limit theorems. So the definition of bounded function. One definition is there. Let A is subset of set of real numbers and let f is function from A to R. Let C is a real number, be a cluster point of A. B is a cluster point of A. Then we say F is bounded on a neighborhood of point C if there exists a delta neighborhood of C and a constant real number m which is positive such that all the values of function are less equal this m for all x in A intersection a delta neighborhood of point C. So it is very simple that function is bounded if all the values of function are less than some real number, right? So the first theorem is that if A is subset of real numbers and f is function from A to R has a limit at point C, then f is bounded on some neighborhood of point C. The proof is very easy. If the function has limit, then in some neighborhood of point C, then it is bounded. So proof, let f has limit, so let limit of f in the neighborhood of C is L. So let for epsilon equal to 1, there is, as the limit exists, so for any epsilon delta must exist. So for epsilon equal to 1, delta also exists, so that this modulus fx minus L is less than epsilon. Epsilon we have chosen it to be 1 when x belongs to a neighborhood of point C. 0 less than mod x minus C less than delta. So now consider this modulus of fx minus modulus of L. So this is by triangle inequality. This thing will be less equal modulus fx minus L by the lemma of triangle inequality, and as we have considered, it is to be less than epsilon. So modulus of fx will be strictly less than modulus L plus 1 if x is not equal to C and x belongs to a deleted delta neighborhood of point C. Intersection with set A. Yeah. And if point C does not belongs to A, then take this m to be modulus L plus 1, and if C is in A, then take m to be maximum of or supremum of modulus f of c and modulus L plus 1. So in both the cases, modulus fx is less equal m. This implies fx is bounded. Function is bounded. Now, next theorem. Let A is subset of real numbers and let f and g are functions. F and g are functions on set A to R. Let C is real number be a cluster point or limit point. And let B is real number. So the first result, if limit of f in the neighborhood of point C is L and limit of gx in the neighborhood of point C is M, then the limit of fx plus gx in the neighborhood of C is L plus M. So it is very easy part. Limit of fx minus gx in the neighborhood of C is L minus M. Then limit of fx upon gx divided by fx multiplied by gx is L into M. The limit of fx divided by gx is equal to L by M, and limit of where this here g of c is not 0 and m should not be 0 in this case. Limit of b into f of x is b into L. So the rest are some examples. So this is assignment to you. Okay, let me take it on the page. Assignment is that by epsilon delta definition, show that number 1, limit of x by 2 when x tends to 1 is half. Second, limit of x tends to 1, x plus 5 upon 2x plus 3 is 5 by 3. Then next is limit of 2x plus 3 upon 4x minus 9 when x tends to 3 is 3. Then the next is limit x tends to 6, x square minus 3x upon x plus 3 is 2. Then the next limit x tends to 2, x square plus 4x is 12. Okay, this much is sufficient. Number 2. Show that limit 1 by x as x tends to 0 does not exist. Number 3. Show that limit sin 1 by x does not exist. Try to draw both the graphs. We have seen the graph of 1 by x, which is like this. Yeah, it is graph of 1 by x. So why it is not defined in the neighborhood of 0, right? And that of graph of sin 1 by x. So as the graph of sine lies between +1 and -1, right? So graph of sin 1 by x is this. So it is very difficult to predict what is happening to the graph in the neighborhood of 0. That's why the limit does not exist. So try to show the next example 4. Show that limit x square plus 1 into x cube minus 4 is 20. The next, limit x tends to 2, x square minus 4 by 3x minus 6 is 4 by 3. You have to show this by definition, and this is directly, not necessary to use the definition. Okay. Then next, number 6. Determine limits the limit x tends to 1 root x minus 1 upon x minus 1. B, limit x tends to 2 x square minus 4 upon x minus 2. Next, limit x tends to 0 x plus 1 square minus 1 upon x. The next one is limit x tends to 0 x plus 1 upon x square plus 2. So all are very easy examples. These two are something tricky. Okay. Now the theorem. Let A is subset of real numbers. F is function from set A to R, and C is real number. Be a cluster point of A. Now if A is less equal Fx less equal B for all points x in A except x not equal to C, and if limit of f exist, then the limit will also lies between a and b. If the function lies between a and b, bounded below and bounded above by a and b, so its limit will be also bounded by a and b. And the next thing is squeeze theorem. Squeeze theorem, or sometimes it is called as a sandwich theorem, because it is make sandwich of a function between two other functions. So the theorem statement is, let A is subset of R. Let f, g, h are functions from set A to R, and real number C be a cluster point. Cluster point of A. Cluster point means in its neighborhood it have some other points of A also. And if this is the relation between the function f, g and h, fx is less equal gx is less equal hx, and it is true for all x in A and which are not equal to C. And if the two leftmost and rightmost functions has limit and it is same, limit of fx exist is equal to L and is also same as limit of hx, it exists and it is equal to L, then limit of the middle function also exists and it is also equal to L. That's why it is a sandwich of function between two other functions. So the limit of gx is also exist and it is equal to L. So for example, number 1, limit of function x raised to 3 by 2. Now since it is the neighborhood of 0, so in the 0 neighborhood we can have 0 less than x, in the neighborhood of 0, x less than root x less equal 1, for 0 less than x less than 1, right? That is x less than x raised to half less than 1. So if I multiply this equation throughout by x, so I'll get x square less than x square less equal x square less than x into x raised to half, so it x raised to 3 by 2 less equal x. And we know that limit of x square when x tends to 0 is 0, right? And limit of x when x tends to 0 is 0. So leftmost function has limit 0, rightmost function has limit 0, so the middle function has to be limit 0. So by squeeze theorem, limit of x raised to 3 by 2 will be also 0. The second example, limit of sine x is also 0. Why? Since in the neighborhood of 0, minus x is less equal sine x is less equal x for any x, right? For all x greater equal 0. And in this case we know that limit of minus x when x tends to 0 is 0, limit of plus x when x tends to 0 is 0. So by using the sandwich theorem, so limit of sine x is also 0, right? Similarly, I am giving some homework to you. Find limit of cos x when x tends to 0 by squeeze theorem. The next one, find limit of cos x minus 1 upon x when x tends to 0. The next one is limit of find limit of sin x upon x when x tends to 0. The next example, it is a homework. So, and the next example, the limit of x into sin 1 by x is also 0. Why? Sin 1 by x, this limit, we know that it does not exist, because I have given this example to assignment. Right? So for sine function, since we know that mod of sine theta is less equal 1, right? It means minus 1 less equal sine theta is less equal plus 1. So minus 1 less equal sine 1 by x for any angle. So the angle is 1 by x is less equal. Now I multiply the equation inequality throughout by x. So minus x less equal x into sine 1 by x is less equal x. Now limit of the leftmost function is 0, limit of the rightmost function is 0. So by squeeze theorem or sandwich theorem, both limit exist and equal to 0, therefore limit of middle function x into sine 1 by x is exist and is also equal to 0. So solve all your assignment and do the homework. Then the next homework, limit x square into sine 1 by x is also 0. So take it as a homework. Okay. So we left with one topic from this chapter.